Yep.
Good morning, everybody. My name is Brent Jividen. I'm the Executive Director of Client Relations for Gardner Service. With me today, we have Jake Kuhn, who is Business Development for AI. Wave, Jake. We have Mike Summers, who's head of our healthcare market development. Wave, Mike.
Morning.
And Kayla Franzek, in the dark, it seems. Kayla is in marketing for Gardner as well.
Hi, everyone.
Thanks for joining us. As a brief introduction, I'd like to say in my 30 plus years in the industry, I have seen maintenance staff shrink the size down to a fraction of what they were when I started. There's been constant operating pressure over the years to do more with less. In fact, I do remember a number of years ago, a maintenance guy said to me, "When is less going to get here?" And he wasn't joking. At Gardner, we started our building analytics over 8 years ago, and using data to do more with less. And we've refined this process with some of our largest customers over those years. And Jake today is going to walk us through what we call building AI. And the AI is applied intelligence, not artificial intelligence. With that, I'll turn it over to you, Jake. Thanks.
Thank you, Brent. I am going to share my screen here and pull up our presentation. One moment here. And so just 1 second. Thought I had it pulled up. Okay, so thanks for the introduction, Brent. And to build off of what Brent said, we are fortunate to speak with a lot of health systems. We work with a lot of health systems and have a lot of conversations with folks that are responsible for their buildings, maintenance and included, and HVAC maintenance obviously included with that. So through those conversations, we have gained some really, I think, insightful knowledge and important feedback from the biggest obstacles and challenges faced with maintaining a healthcare system, those buildings involved with that. So today we really do want to share those trends, those insights that we've gained, some things that we've learned from our own research, and how that might help support you making decisions with your building maintenance moving forward. So through these conversations, through these talks, we hear that first and foremost, ensuring a comfortable environment of care, that's the top of their priority list. So ensuring those patients, the doctors, physicians, nurses are comfortable while they're, in the facilities being managed by these healthcare systems. Of course, something that's being emphasized more and more is reducing energy and being more sustainable. So these green initiatives are popping up and really, being something that needs to be focused on. And then ensuring health, safety, air quality. COVID obviously has made this a huge priority, especially in these facilities where there are sick patients. And then the HVAC equipment itself is very expensive. So replacing that equipment and ensuring that you're doing the best you can to extend that equipment life is a big part of the job, as well as asset managing and planning when those replacements will occur, ensuring that you have the finances to make those replacements happen. The challenges, limited maintenance and capital budget. Brent spoke of this, right? So always being expected to do more with less. And these are conversations, everybody is telling us this. We were speaking with a healthcare, Brent and I, a system a few weeks ago, or a few months ago. They had 2 positions that they were trying to fill for over 2 months. And they didn't have any leads or likely candidates to find those positions anytime soon. And then operational commitments and expectations spoke to that. And then the increasing complexity. So these new pieces of equipment are becoming more digital. Building automation systems are adding to the complexity. And I'm going to speak a little bit more to that. But the things that are being relied on to do this huge job, right, for all of these different roles, these different hats that need to be worn for the maintenance of this building are the traditional conventional methods, things like on-site fix and repair, preventative maintenance. And for those two things, maybe you have your own technicians on payroll that are supporting that, or you're using a local contractor. Then you have a building automation system as well, something that's really, really important for the transparency into your overall HVAC system. Well, these traditional methods are being used for modern systems. And these modern systems are introducing at least 100 times more failure points, right? So this digital equipment, these building automation systems, the complexity that they're adding makes it very challenging to really identify where the problem is when you do have a comfort complaint, right? So things like, a comfort complaint might come in, and now you have 1,000 different places to look and check for that issue, whereas in the past, it might have been easier to identify. So let's talk a little bit more about that complexity. Well, where does it come from? Why is there more complexity? Well, a modern piece of digital HVAC equipment has over 260 million data points generated just by 1 year, just in 1 year, right? So in order to have all of this data transmitted from this mechanical equipment back to your building automation system, there is a lot of back-end hardware that needs to be in place, giving more opportunity for these issues to occur. So there's this upside, right? You have all of this data, but you have to use it. And the disconnect is right now, even the best operators out there are only utilizing 3% of that data. So these studies come from Gartner, not Gardner, and Penn State, combined study here. And it really highlights the challenge of having this hardware, this equipment that has all of this data transmission and data points, all of this ability, and the disconnect with the operators only utilizing 3% of it, right? So this building automation system, what is it doing? Because it's important. We've established that it's a part of a traditional conventional maintenance program, overall maintenance program. Well, I think the best way to understand what it does do is to first highlight what it doesn't do. So 75% of these issues are going undiagnosed, right? So all of those faults and failures that are underlying causing your comfort complaints, your building automation system is not automatically catching those. And in fact, building automation systems might alert you with alarming. Sometimes you can hear of alarm fatigue. You get so many alarms that come in, you don't really know what to alarm. But that's past the point of that equipment failing. This is not giving you a warning sign saying, hey, there's a little something going on here. You might need to pay attention to this exact location or place this part before it causes a comfort complaint, before it causes a piece of equipment to go down. So it also, so let's talk about what it does do. It gives you the ability to schedule, to put set points in, maybe do some light programming, and it allows you to put in overrides. So the way that building automation systems are not being used now, the best way to describe it is putting a Band-Aid over a bullet wound with these overrides. You're not getting to the root cause of the issue. You are changing, you're adjusting something in the system, some setting that's masking what the root cause of the issue. And the problem with that is there's untold damage to the rest of your equipment, causing more stress on other pieces of equipment, other parts. That's ultimately going to lead to over 20% more energy waste. And that statistic was brought to us by the US Department of Energy. So building operators are misusing or misdiagnosing issues and using overrides to fix these problems. Again, putting Band-Aids over bullet wounds. And a lot of the time, it's not their fault. Time is restricted. Top priority is comfort. So that's what a building automation system is, and that's how it's used. These other things that we're relying on, right? Preventative maintenance. That's something that Gardner personally believes in very much as part of a complete overall maintenance program. But I think this study really highlights, again, what a preventative maintenance contract is and is not, what this preventative maintenance work does. Maybe it's your own team that's doing it. Maybe they're on a set schedule of going, getting eyes on pieces of equipment to do those visual inspections. The largest study ever done, though, by New Buildings Institute, looked at over 20,000 HVAC units, found that 44% of refrigerant circuits, 64% of economizers had some sort of fault or failure that was preventing peak performance. 41% of those units had an airflow issue. 57% of the thermostats and 18% of the sensors were faulty, right? So this is preventing peak performance. And these issues aren't being caught by preventative maintenance contracts. That's not what those preventative maintenance contracts are for and what they're capable of. That's a snapshot in time that you're looking at that piece of equipment. You're not trending data. You're not finding the anomalies. You're not finding these underlying faults or failures that are causing your system issues, right? You're cleaning coils. You're starting up boilers before cold season, starting up chillers, testing chillers in the springtime. Right? That is very important. You really should have this preventive maintenance, a maintenance program in place. But what it's not doing is not finding the underlying issues. So let's talk then about labor, right? So we have these complex, systems with all this data being used, this new modern equipment. Well, part of the problem with getting your technicians or getting good support is that there's not a lot of them out there. 39% of HVAC positions are currently open. That number is supposed to jump up to 53% by 2025. These studies came to us, they were published by Contracting Business Magazine, right? So you have an aging workforce. It's something that we experience, certainly. And it's now an aging workforce that is expected to learn new complicated equipment and new complicated building automation systems when their time is already spread very, very thin. And believe me, this is, a challenge that Gardner absolutely faces and is overcoming with the use in large part of data and technology. So we're talking about these traditional methods, right? We talked about building automation systems, preventative maintenance, on-site repair. Well, what does it look like ideally when a comfort complaint comes in? You identify that issue, you investigate it, diagnose it, solve the problem, wipe your hands clean, you're good to go. That's the ideal situation right now, right? But everybody has a plan until they get punched in the face. And more likely than not, when you have a comfort complaint and it comes in, it's going to look a lot more like this, right? So I was with a customer a couple of weeks ago. They were describing the challenges they had when a comfort complaint came in. And it wasn't just one comfort complaint. There were multiple spaces that were having comfort issues. So the director of facilities called his HVAC tech that he has on payroll in, said, hey, this is what's going on. Can you investigate? The guy opens up his laptop, looks at the building automation system. That's the first place he goes. He's trying to look around, doesn't have a ton of experience or training with it. He admitted that he couldn't change the set points in those specific rooms. He just didn't know how. So that wasn't going to be able to solve the problem. He didn't really even know how to do that override we discussed previously. So he goes into these spaces where there are units that have control of them. We call them VAV boxes. He can't find the issue with those units, right? So now he's forced to go on top of the roof. He's got to go look at these rooftop units, unfortunately, and try to find out what the issue is. He can't find out what the problem is. He believes that rooftop unit, after doing some investigating, is responsible for those spaces that are causing the issues. Tells the director, hey, can figure it out. So now they have to call truck roll in, right? Truck roll comes out a couple days later, they're swamped. So they go to those units where they believe the issue is. That's not the unit that's responsible for those spaces. So then they have to go to a different unit. That's the one responsible for those units. The guys, after digging around, looking at the equipment for a couple hours, figures out what the issue is, goes back to his truck, tries to find the part to replace it, the tools to replace it, doesn't have them. Has to go back to the office. Now this is an additional truck roll, maybe the next day or the day after, can't recall the exact timeline. He's out there and can finally fix the problem. But now we're talking over the span of a week later, 2 truck rolls, 10 hours of contract work for that technician to come out and fix this problem. This is the modern day equation for solving these problems, right? It's not linear, it's not simple, it's very complicated, and usually takes quite a bit of time to solve these problems. So what is the cost to you, the end user, right? What is this reactive maintenance model, this traditional conventional method mean to you, the end user? Well, it means that there is overspending by as much as 30%. And where does that come from? More energy consumed, 70 to 75% more breakdowns, 35 to 40% more downtime, and a lot shorter lifespan of this equipment. This is going to result then in more comforting issues. The reliability obviously isn't there. Trying to plan for these breakdowns is very challenging. And your operational costs, obviously, as a whole, are going to be much higher. So what is the alternative? What is the new way forward? How do we go from this reactive maintenance model to a different model? And what is that model? Well, I can tell you, it all starts with using the data, right? So all of that data that we have, right? 262 million data points in a year. It starts with accessing it and using it, not just using 3%, using the full breadth of that data, right? And what does that do? Well, it allows you to improve your labor's efficiency, that on-site fix and repair. By using that data, you can send them to the right locations. Your preventive maintenance, all of a sudden, your preventative maintenance folks that are responsible for those run-throughs, that checking the visual inspections, that's what they're doing. They're not being dragged into other problem areas in the HVAC system. And you're utilizing, like I said, the full breadth of that data. The benefits are not just monetary, they are efficiency, they are future reliability of your equipment, and it shifts the way that your maintenance program is set up, right? So I said it starts with data, but that's not where it ends, right? So this is data-driven, but powered by people, right? So this is our war room here. We have 18 certified energy managers. We have over 30 degreed engineers, over 100 technicians, both mechanical and automation, that are responsible for using this data and translating it into actionable items, either investigating and solving those issues remotely, or sending out a technician with a very specific issue and solving that problem. So building AI, we describe it in 4 steps. Our process, we were talking about this idea of utilizing data, having the people to utilize that data and drive real results to get to those faults or failures that I described, 18% of those sensor issues, right? To solve those problems before they become comfort complaints. Well, this is our process to do it. First, we have to access that data. We then have to assemble it so it's meaningful to us, so we can identify those problem areas. Then when we do, we run further reports, more detailed reports. We drill down, we analyze those reports to identify the root cause of the issue, and then we act and drive home results. So I'm going to run through an example of how we do that, our process, right? What it looks like. This is our space comfort scorecard with just the raw data that we're pulling in every 15 minutes, 365 days, 24/7. So what we're doing is we're pulling in, you can see on the side, the left-hand column here, what that is are these different spaces. And at the top, we have the dates. every 15 minutes in a day, we're pulling that room's or that space's ability to hit the set point, the temperature set point. If it hits that set point, it receives 100 out of a 0 or 100 out of 100. If it's 3 degrees or off or more, it receives a 0. And it's a linear grading scale in between. So if it's 1.5 degrees off, it receives a 50, right? So now we average those scores in a day, and it gives us a score for that day. So now we look across the span of a couple of weeks in this example, and it gives us a heat map of this space. So now we can direct our attention after we organize it and assemble it to where those issues are. So here we can see that there is a lot of these rooms that are labeled as bad or poor performing are labeled with an 8. Okay, so now we can direct our attention to this unit 8, this air handling unit that's causing the issues in a lot of these rooms. So what do we do with that information? So now we go into that unit, we run some reports, right? And what we find here is that there is a sensor, that's that green line, that's what we see represented here. The blue line is the outside temperature between 20 and 40 degrees. So we understand that this is in winter operation. And then red line is the outside air damper. That's 100% open. Our green sensor is reading how much outside air is coming in by the air damper. Well, our guys can see that there's a disconnect here, right? It's reading at 0, but the air damper is all the way open. That should be reading a lot higher than that. Well, what is it causing? Well, it's causing these comfort complaints. And similar to the example that I gave to you earlier, this issue is happening in different spaces. By having access to this information, by this report, we're able to catch this issue before it's causing comfort complaints. Our technician on the back end is told, hey, this is a sensor that's faulty. We order the part, he goes on site, he replaces that sensor. Now on the right side of this graph, we can see that the sensor is recording the correct amount of air that's coming in. Our set point changes, and now we're operating optimally now. Things are running smoothly. And this issue here is something that's going on without the knowledge of the operator. He's just getting comfort complaints. He just believes that the weather is getting too cold at night. The temperature is getting too cold. So he has to run this thing 24/7, right? So that's causing untold damage to these units that now have to handle all of this cold air, trying to heat it very quickly, causing premature equipment failure down the line, causing energy waste, causing stress on the fans, you name it. Now being identified and fixed remotely through then a technician that goes on site, and with that knowledge can fix that issue much more quickly. And when you compare it to the example I gave it before of running around and trying to identify the issues, you can see how as these problems are solved, how they compound and free up time, money, and energy. Ultimately, you're improving through this process. When we talk about act and implement in the 4th step here, you're improving the comfort of your overall building by taking these issues on one by one, by running these issues, trending this data, finding these anomalies over time. And you'll see that when these comfort complaints are improved, it also coincides with energy savings as well. They go hand in hand. So we talk about reporting. That last report was our space comfort scorecard. What we have here are some different metrics being measured, something that we've prepared for different healthcare systems where they have to keep records of this. So whether that's in a binder or maybe on Excel sheet, we have dynamic documents that we can share and keep track of this information so it's readily available when they need it. So this is more on the reporting, the acting and implementing side, something that does notify us when there are issues, but is equally helpful for the clients that we work with on the healthcare side of things to keep track of these other metrics that they have to abide by. So then I also want to talk about here a different way that we gather that data and identify the issues that then direct us toward that deeper layer of reports. So this is our targeted operational review. So what we do is we put these tight parameters on specific pieces of equipment that we know when they're outside of those parameters, it's an alarm that goes off for us, a notification that we get that says, hey, go look into this piece of equipment, right? So then we're able to run that deeper layer of report. This is an example here where we have a supply fan that's running. You can see that that black line is how much the supply fan is running, right? 100%. Well, the red line is how much pressure is actually coming through. So we can see then that the blue line is the static set point. So with the fan running at 100%, we're not even able to get close to that set point, right? So that's, again, a trigger for our guys on the back end that are looking at these reports, digging into this type of data and information all of the time. They're experts. This is, something that they see every other day. So they can identify this issue, say, hey, something's going on here with the supply fan. Maybe this isn't something we can specifically diagnose, but there is an issue here. And we can direct our technician directly to the spot where this is causing a problem. This is unique. This is interesting. We talked about indoor air quality. I just wanted to focus in on this example real quick, because this is a problem that your operator would never know about if you're not looking at this lower level, this deeper level of data, right? If you're not using the 97% of data that's really available from your building automation system. And this is an indoor air quality issue because you're not getting, that red line is showing, you're not getting the air changes you need to maintain a healthy and safe environment. Again, something that's not information that's not readily available. It is not an operator's, fault. This is new technology, new services that we're providing that allow us to dig in, do what we do well to give you this information. So back to kind of other areas that we get into, other reports that we show and allows operators to do their job better, enhance their abilities, their times. It's no secret that HVAC equipment is expensive and lead times are long. And the supply chain issues, is something that Gardner feels very much, and it's a constant challenge, right? So when we think about our customers and clients, how they can best get the products, equipment that they need, it's our job as a partner to help support them and realize the obstacles that they face in purchasing new equipment. So one of the things that we do is we put this asset management dynamic document together. We take inventory of the equipment, we get the age, we have expected life, and just simply by documenting this to start with, adding notes on this piece of equipment as it comes in, recommended repairs that maybe extend equipment life, having that dialogue with our partner on what replacements are going to have the most bang for their buck. This is something where we take this partnership to the next level and really support the decisions that need to be made, not just on the maintenance side of things. Gardner is a huge company. We're a distributor of Daikin, right? So we have the ability to help support in these other areas with expertise, not just revolving around maintenance and service. And by working with you on the maintenance and service, we obviously gain more information that can help you with this other part of operating a facility. We also get into benchmarking, right? So part of our job here is really to help you establish your baseline, where you currently are. Energy is a great way to do this through utilities, right? So we have electric, we have gas utilities, we have water. By taking this in and establishing your benchmark and putting your information through Energy Star certification, right? This is a third-party organization that takes into all of the weather, building size, building type, all of these different factors into account and compares it to its database that's full of buildings just like yours that you can compare apples to apples against your peers. So it gives you, again, this baseline. How are you doing with utility spend? So this is an example of a building that receives a 21 out of 100. And we know to get Energy Star certifications, it's a 75 out of 100. So we can identify how much money they're spending with their current certificate or with their current score. And then based on what their score would be or their spend would be with a 75 score, we can look at that delta, that difference, and we can say, hey, this is our goal. This is where we see the opportunity. This, as your partner working together with us, this is what we're trying to get to. So it allows our customers to see how working with us can help them improve, establish where they're at and improve upon it, right? You can't improve what you don't measure. This is the first step in the process and can be very enlightening to our customers. Not only are, this building AI, our focus here is on the operations side, right? It's not necessarily on the supplier side, negotiating gas and electric pricing, but by establishing this baseline, looking at your utility spend, that's also something we can support, right? We have experts in performance solutions, different solutions, and working with various suppliers where we can make those connections and support you there as well. And this is, I think, just an interesting example that we like to bring up. So this is a LEED certified building. And as we established their Energy Star certification, we could see that it was a 69 out of 100, right? So it was a brand new building. The assumption is, hey, this building was just constructed. It's optimized, right? It's perfect. It's going to be 100 out of 100 on Energy Star certification. There are going to be no comfort complaints. Well, the reality is that when your building is commissioned, retro commissioned, it's a point in time without occupants, without the seasons changing. It is not looking at data or trending over time. The seasons changing, weather changes, occupancy, things that you truly cannot plan for in the construction phase. So this is when we took over. You can see we started partnering with this client. We got them up to a 98. So it was based on our ability to look at that trending data, optimize their sequencing, their programming for their building as we got that data over time, right? So it's a dynamic commissioning versus a retro commissioning. And again, this is just to say, when you think about a new building that's constructed, it's not perfect. It's not good to know. And the maintenance of that building is something that's not always focused on, especially with the financial challenges in healthcare today, putting that money aside to maintain those buildings. And again, I think this is just something to highlight. By investing on the front end, you could be ultimately saving yourself a lot of headaches, pain, and ultimately dollars spent on the front end. So that's building AI. Appreciate everybody's joining us here today. I'm going to stop sharing my screen here.
So at this time, I'd like to point out that I see we have 2 questions already, but at the bottom of your screen, if you move your cursor, the chat bubble or the Q&A bubble pops up, and you can type in any question for any of us. So let's go ahead and get to the first question. Let's see if any more come in. Kayla, do you mind reading the first question there?
Sure. It looks like, let's see, pull it up. Does it matter what type of automation system is existing?
No, yes, it does. I'm sorry. So it's as long as it has BACnet language, then we can work with it. But there are also, integrations. We have a full automation construction line, right? So we install new automation systems, and there are certain integrations, some easier, less expensive than others, that make it possible to work with building AI. And in certain situations, there are different types of partnerships that we do. It could make sense for us to help with that investment. Not in all cases, I can't guarantee that, of course. But depending on the situation, there are ways that we could potentially work creatively to get access to that data. Brent,
Okay,
do you have
cool.
anything to
And then
add on that one?
looks like the second one is, can this platform be managed by anyone, or is it strictly supported directly by Gartner?
Another great question. So the analytics that we do on the back end, we're able to take all of that data, and the real magic is, right, we have all this data, but we have the people that can mine the data, run the additional reports to really identify that issue. And then once we have that information, we populate a document for our technicians or the client or partner who might have the chance to look at those issues themselves. So we do work with certain clients where they have a full team. Case Western Reserve, they have over 10 technicians in certain parts of their campus that handle all of these issues. So we populate with our data analytics what we call a corrective action log, and they use that to solve these problems, solve these faults and failures before they become bigger issues. So while we do handle the analytics side and populating that corrective action log, that's something where our expertise is required. We do create this log that's able to be used and translated and to solve the problems on site. And we also have a help desk that's able to access the system, the building automation system, that can help support the on-field, the technicians from our partners trying to solve those issues as they are doing so.
If I can just add to that, I want to make sure, I'm not sure if the question is if we manage the program. I just want to be clear, we don't just hand over data and say, here you go, good luck. There's a certain amount of special sauce to this that our energy engineers do write the programs looking for these anomalies. But to Jake's point, we do work collaboratively with our clients in addressing those issues. And we have the ability with our service techs to perform some of these corrective actions. But we also work with existing maintenance staff like at Case Western and other places where they take the corrective actions and resolve some of these issues. So I just hope we answered that question. Is there any more questions? I'm just waiting a little bit here to see if anything else comes in before we wrap up. All right, if nothing else, I guess I would like to just add, again, building on Jake's point, two of our biggest customers that we do analytics with are Case Western Reserve, where we've been working there in developing this program, but also working with them for, I would say, probably 4 or 5 years, and it's working well there. And we've continually expanded the program there. Kent State University is another one where we have the responsibility of managing their 9 regional campuses and assuming the risk of replacement equipment. So if we're not doing preventive maintenance and something breaks, we take full responsibility for that. And the analytics that we've applied there help both us on the preventive maintenance cost, making it more predictive and lowering that cost, but it also helps on the client side assuring comfort and things like that, which is what they're in the business of, providing a productive, comfortable learning and working environment. So those are two of our biggest customers. If anybody on this presentation has additional questions and wants to talk more about it, of course, that's what we're here for. Reach out. I'm not sure where the original email, Mike, did you send that out? If they have your email on this invite. But anyway, whoever sent the invite to this meeting, please feel free to reach out and establish some kind of a contact, and we can follow up with you individually. We'd like to thank you all for attending today and taking your time out of the day. Hopefully we didn't go, 45 minutes. I think we're in the window of our commitment. So we appreciate that, and we appreciate your time. Thanks, everybody. Have a great day.
Bye.